The first one will be called getIncompleteToDos, export const, getIncompleteToDos. And we're going to stop here for a minute. Before we go on, there's another ecosystem tool we're going to add to our project. When we need to create selectors that make use of other selectors, for example, our getIncompleteToDos selector will need to use our getToDos selector, there's a tool called Reselect that we can use to build more complex logic on top of simpler selectors, and even combine different selectors if need be. So let's start off by installing the Reselect library into our project by opening up a terminal in your project and typing npm install Reselect. And once that completes, we're ready to see what Reselect can do. So let's go back to our selectors.js file and implement this getIncompleteToDos selector that we need for our app. I'm just going to implement it first using Reselect, and then afterward I'll explain it in more detail. So using Reselect to create a selector looks like this. We start off by importing something called createSelector from Reselect. Import createSelector from Reselect. And then we'll implement our getIncompleteToDos selector by saying something like this. Equals createSelector. And we pass our getToDos selector as an argument. And for the last argument, we're going to define a function that takes todos as an argument and says todos.filter and gets only the todos that are not completed from this array. Not todo.isCompleted. So that's what a Reselect selector looks like. So how does it work exactly? Well, as you can see, we're using this createSelector function, and basically this function takes a variable number of arguments, each of which is some sort of selector, and the last argument that we pass to it is a function whose return value is the return value of the entire selector. So in this case, calling getIncompleteToDos with state as an argument, from inside a map state to props, for example, we'd do this. This would return all the todos in the state whose isCompleted property was false. Now, the really interesting part of this createSelector function is that we can pass as many selectors as we want here, and the last function that we pass to createSelector will get the result of all the other selectors before it. So just as an example, if we not only needed the todos from our Redux store, which we're getting using our getToDos selector here, but we also needed to know whether or not our todos were loading, we could add our getToDos loading selector as an argument like this, and then the return value of that selector would get passed to our final function as a second argument. So if we wanted to use this isLoading argument to modify the return value of getIncompleteToDos, for example, if for some reason we wanted to return an empty array whenever the todos were loading, we could do that here like this. We'd say isLoading, and then use a ternary operator to return an empty array if it is loading, and otherwise we return the incomplete todos. And I'm just going to delete this because this is not what we want for our application right now. So in theory, we can add as many other selectors as we want to this function. Now granted, we've only seen it with 2, but you get the point. And the cool part is that we're not only limited to passing simple selectors such as getToDos or getToDos loading to createSelector, but we can also pass in other selectors that we've created with createSelector. And this allows us to build up an ever more expressive library of selectors that our components can use to transform the data in our Redux store into a format that they can use. So now that we've created our getIncompleteToDos selector, let's create another selector that will give us all of our completed todos. And this is going to be very similar to our incomplete selector. We're going to say export const, and we'll say getCompletedTodos equals createSelector, with the arguments getTodos, and the final function here is going to simply take the todos from the state and say todos.filter, and then it's going to get all of our completed todos by saying todo.isCompleted. And that's really all we need to do. But before we move on and incorporate these selectors into our components, there are 2 things I'd like to note about these kind of selectors. The first thing you should notice is that just like our components, these higher order selectors that we've defined, our incomplete and completed todos, have no idea how our data is formatted in the Redux store. Nowhere here are we referring to state.todos.data or state.todos.isLoading. So even our higher order selectors rely on our lower level selectors, such as getToDos, to worry about the exact format of our data in Redux. So while it might have seemed a little silly beforehand to define a super simple function like getToDos or getToDos loading, in the long run it really helps us out. And that's because now, as the number of selectors grows, we won't be referring directly to state.blah in any of our higher order selectors. So if at some point we need to change the way our data is formatted in Redux, from the point of view of our selectors, it'll essentially be a one-line change. So that's the first thing to note about our selectors. The second thing is that the selectors we create with Reselect's createSelector function use something called memoization. So what on earth is memoization? Well, to put it simply, let's say that we have a function whose output is determined solely by its input. In functional programming, we call these pure functions, and all our selectors so far are good examples of this. Now, if we call a pure function twice in a row with the exact same arguments, it'll give us the exact same result. And because of this fact, if we were to run our entire function again the second time we call it, we'd be completely wasting computational power, since we could have just saved the result the last time this function was called and returned that pre-computed result when we saw the same arguments were getting passed in. So with that all in mind, take a look at our getCompletedToDos and getIncompleteToDos functions. The only thing that will change their output is the todos.data array in the Redux store. Now granted, at the moment our entire store is still pretty small, but in a full-sized React Redux application, our todos array would likely only be a tiny part of our entire Redux store, so it wouldn't make sense to recompute the completed and incomplete todos every single time our component's re-rendered. So that's one of the nice things that this createSelector function does for us. It makes sure that the parts of the state that it cares about have actually changed before completely recomputing the result it returns. And this is a somewhat important point to understand, because on the surface, it might seem like createSelector doesn't really do anything. In other words, it seems like we could replace our getCompletedToDos here, for example, with a function that looks like this. We could say export const getCompletedToDos equals state, and just have a regular function that says const data todos equals state.todos, and then say return todos.filter todo.isCompleted. On the surface, it looks like using createSelector does exactly the same thing as what we defined here, but it doesn't. If we had just defined getCompletedToDos like this, it would recompute every time our app re-rendered, even if the input and output of this function was exactly the same. When we use createSelector, the return value of this function only changes when the return value of the selectors that we pass as arguments changes. So anyway, that's just something to keep in mind when working with Reselect. Okay, so now that we've created some more advanced selectors using the Reselect library, let's incorporate these selectors into our components. Now, if you'll remember, what we want to do is split our to-do list into two separate lists, one that contains the completed to-dos and the other that contains the to-dos that we haven't completed yet. And as a matter of fact, now that we've created these two new selectors here, getCompletedToDos and getIncompleteToDos, this is actually quite easy. So what we're going to do is open up to-do list, and the first thing we're going to do is import the two selectors we just created. So up top here, we'll add getCompletedToDos and getIncompleteToDos. And once we've done that, we're going to go down to our map state to props function, and instead of having a single property called todos that we pass to our component, we're going to split this into two props, one called completed-todos and the other called incomplete-todos, and we're going to use the corresponding selector for each of these. So that'll look like this. Completed-todos, getCompletedToDos from the state, and incomplete-todos, we're going to get the incomplete-todos from the state. And now that we've done that, up at the top we're going to add these new props to our component. So we don't need to-dos anymore, but we do need completed to-dos and incomplete to-dos. So that's easy enough so far. The last thing we're going to do is, instead of having just one list down here, we're going to map both arrays of to-dos, our incompleted and completed to-dos, each with their own heading. So that's going to look like this. We'll say h3 incomplete, and we're going to say incomplete to-dos.map. And then down here, we'll say h3 completed, and we'll copy and paste this and change this to completed to-dos. And if we run our app again, npm run dev, and take another look at our app in the browser, we should see that the changes we wanted are there and that they seem to work really well. And that's the power of selectors at work. So far, we've done a very good job of separating out most of the logic from our components. We have Redux to manage our application state, thunk to manage our side effects, and selectors to make it so that our components don't have to know how our state is set up or contain any logic for transforming the data we get from the state. So we're very close to having components that are truly free of all logic that doesn't belong. We're going to take one more step toward this goal of separation of concerns, and that's by adding something called styled components to our project to make it a little easier to, well, as you may have guessed by the name, style our components. Currently, our app is using CSS modules in order to style how our components look. And this is an extremely common practice, but in my opinion, using CSS modules with React falls a little short of ideal. First of all, having an extra CSS file for every component really clutters up the directory structure. But there's another bigger concern here as well. Let's take a look at an example. Let's say that in some application we have a list of items, and that at any time, one of these components can be selected. Now, if we're using CSS modules to do our styling, what we have to do is set the class on our list items dynamically, depending on whether or not a given list item is selected. And to me, this just sort of feels like an unnecessary intermediate step. It doesn't seem like this kind of logic should be directly inside our components. And things get worse when we want to make some more precise changes to the styling of our components. For example, if we were to have a list of bank accounts, and we want the background color of the list items to reflect the balance in that account. For example, we want it to go gradually from red to yellow to green, depending on how much money is in a given account. And these are things that styled components can help us with. Granted, there are other ways to do this as well without using styled components, but I found that the way that styled components handles this is really my favorite way. So what are styled components exactly? Styled components are what's referred to as CSS in JavaScript, and what they allow us to do is define styling for our components inside of our JavaScript files. Now this has some pretty cool implications. For example, it allows us to define our own UI components that we can pass props to. In the case of styling a selected list item, for example, instead of having to swap styles inside our component, we could just pass a selected prop and use this prop inside our styling to decide what the background color of our element should be. And for our bank account example, we could just pass in a balance prop and use that prop inside our styling to calculate what the correct color should be. And the nice part about this is that it moves all the styling logic out of our main component and into a part of our code whose sole job it is to handle that kind of logic. We'll see exactly how to do this in the videos that